Sir, this is T. Kushi from ITA and my roll number is 37. And my topic for maths for concept video is normal distribution and mean of normal distribution. So let us know the introduction about normal distribution. The normal distribution is also called the Gaussian distribution, is the most significant continuous probability distribution. Sometimes it is also called a bell curve. A large number of random variables are either nearly or exactly represented by the normal distribution in every physical science and economics. Furthermore, it can be used to approximate other probability distributions. Therefore, supporting the usage of the word normal as in about the one mostly used. Coming to the normal distribution definition. The normal distribution is defined by the probability density function for a continuous random variable in a system. So from these two lines, you will get a point that normal distribution can be applied only on those which are PDFs, that is, which are probability density functions, and it should be a continuous random variable. So generally, probability distributions are always continuous random variables. But coming to PDF, you will have two conditions which have to be satisfied so that that probability distribution can be called as PDF, that is probability density function. So the two conditions are f of x should be greater than or equal to 0 in the interval minus infinity to plus infinity, and integral of f of x in the interval minus infinity to plus infinity should be equal to 1. So if these two conditions are satisfied, then that probability is called as PDF, that is probability density function. So let us once again recall the definition of normal distribution. The normal distribution is defined by the probability density function for a continuous random variable in a system. Let us say f of x is the probability density function and x is the random variable. Hence, it defines a function which is integrated between the range or interval x to x plus, giving the probability of random variable x by considering the values between x and x plus. So now let us have a look on normal distribution formula. The probability density function of normal or Gaussian distribution is given by f of x comma nu comma sigma is equal to 1 by sigma root 2 pi into e power minus of x minus nu whole square by 2 sigma square. I am going to repeat this formula once again. F of x comma nu comma sigma is equal to 1 by sigma into root 2 pi into e power minus of x minus nu whole square by 2 sigma square. So here x is nothing but the variable, mu is mean, and sigma is the standard deviation. The commonest and the most useful continuous distribution is called as normal distribution. A symmetrical probability distribution where most results are located in the middle and few are spread on both the sides of the curve is called as normal distribution. So it has the shape of bell. So it is also called as bell curve, or it is also called as normal distribution, or it is also called as Gaussian distribution. Can entirely be described by its mean and standard deviation. So you can describe a normal distribution only by two means. That means only by two conditions or two things. That is mean, which is nu, and standard deviation, which is sigma. So let us see what are the few examples in our day-to-day life where we use this normal distribution. So to measure the body temperature for healthy human beings, the heights and weights of adults, the thickness and dimensions of a product, IQ and standardized test scores, quality control test results, and errors in measurements. So coming to normal curve, let us know more about normal curve. So normal curve is nothing but normal distribution as we already know it. So graphical representation of normal distribution is called as normal curve. So it is determined by the mean and the standard deviation as we already know. And it is a symmetrical unimodal bell-shaped curve. Its tails extending infinitely in both the directions. The wider the curve, the larger the standard deviation and the more variation exists in this process. The spread of the curve is equivalent to 6 times the standard deviation of the process. It helps us in calculating the probabilities of normal distributed populations. The probabilities are represented by the area under the normal curve. So the total area under the normal curve is equal to 100% or equal to 1. This represents the population of the observations. We can get a rough estimate of the probability above a value, below a value, or between any two values. So in this picture, you can see the curve of the normal distribution. That is, as we already learned, that the normal curve is symmetrical unimodal. So symmetrical means it is divided equally on both the sides. Since the normal curve is symmetrical, 50% of the data lies on each side of the curve. So 100% will be divided into 50% and 50%, and the line which is dividing a graph into two equal parts is called the mean of that line. So coming to standard normal distribution, which is denoted by Z, or it is also called as Z distribution, a common practice to convert any normal distribution to the standardized form and then use the standard normal table to find the probabilities is called as standard normal distribution. The standard normal distribution or Z distribution is a way of standardizing the normal distribution. It always has a mean of 0, that is mu is equal to 0, and a standard deviation of sigma, that is equal to 1. So coming to the formula for converting a normal distribution into a standard normal distribution, which is denoted by Z is equal to x minus mu by sigma. Here, x is nothing but the data point in the question. Z is a measure of the number of standard deviations of that data point from the mean. Mu is the mean, and sigma is nothing but standard deviation. There are different forms of Z table. The first one is cumulative. It gives the proportion of the population that is to the left or below the Z score. Complementary cumulative gives the proportion of the population that is to the right or above the Z score. Cumulative from mean gives the proportion of the population to the left of the Z score to the mean only. So you have three different types of Z tables. By using these Z tables, you will find the values of Z. So normal distribution is nothing but it is a limiting case of binomial distribution under following conditions. N, the number of trials is infinitely large, that is n tends to infinity, and neither P or Q is very small. So by these two conditions, we can say that normal distribution is the limiting case of binomial distribution. The normal distribution of a variable, when represented graphically, takes the shape of a symmetrical curve, as we already know. So now known as the normal curve. The curve is asymptotic to x-axis on its either sides. The curve is well-shaped and symmetrically above the line x is equal to mu. Mean, median, and mode of the normal distribution coincide, that is Z-shape. X-axis is an asymptote to the curve. The tail of the curve never touches the horizontal x-axis. So as you all remember, the tail, both ends of the tail will never touch the axis of x-axis. No portion of the curve lies below the x-axis, as f of x being the probability function can never be negative. The points of inflection of the curves are x is equal to plus or minus mu sigma. The curve of a normal distribution has a single peak, that is, it is a unimodal. So it has only single peak. So it is called as unimodal graph. As x increases numerically, f of x decreases rapidly. The maximum probability occurring at the point x is equal to mu, and it is given as p of x max is equal to 1 by sigma into root 2 pi. So now we are going to derive the formula for mean from the normal distribution formula, the theorem of mean for the normal distribution. So as we already know, the formula for normal distribution is f of x is equal to 1 by sigma into root 2 pi into exponent of minus of x minus nu whole square by 2 sigma square. So where nu and sigma are two parameters with sigma greater than 0, by definition the mean we have E of x is equal to, we are going to integrate the Gauss PDF or normal distribution formula. We are going to integrate it between minus infinity to plus infinity. So minus infinity to plus infinity of x into 1 by sigma root 2 pi exponent of minus x minus nu whole square by 2 sigma square into dx, which using integral properties can be written as minus infinity to infinity x by sigma root 2 pi exponent of minus x square by 2 sigma square dx plus minus infinity to infinity nu into exponent of minus x square by 2 sigma square by sigma root 2 pi. This will be your equation 1. For the first integral, we'll call it as I1. We'll have to use additivity. Swapping the integration limits in the first we have. So we are going to swap it. So the integration interval becomes I1 is equal to minus of 0 to minus infinity x 1 by sigma root 2 pi exponent of minus x square by 2 sigma square dx plus 0 to infinity x by 1 by sigma root 2 pi exponent of minus x square by 2 sigma square. And using again integral properties, we'll have e of x is equal to minus infinity to infinity nu by sigma root 2 pi exponent of minus x square by 2 sigma square dx. Now we are going to multiply by sigma root 2 to obtain the following relation. So e of x is equal to minus infinity to infinity nu by root pi into e minus x square dx is equal to 2 nu by root pi 0 to infinity e power minus x square dx. The last term, because the integrated is an even function, so you are going to write it in that form. Now, after all completion of this thing, you are going to get the conclusion as 2 pi root pi integral 0 to infinity e power minus x square dx is equal to limit tends to t to infinity 2 pi root pi integral of 0 to 2 e power minus x square dx, that is equal to limit t tends to infinity of t, that is equal to 1, where ERF is the error function. So we end up with E of x is equal to mu, as we have already defined that nu, mean and standard deviation coincide, and as we all know standard deviation value is 1. So E of x is equal to nu. That is, the parameter of nu is the mean of the standard deviation. If x is the normal distribution with mean 30 and standard deviation 5, so we are going to find the probabilities of x greater than or equal to 26, less than or equal to 40, and x greater than 45. So first, here we already know nu is 30, standard deviation sigma is 5. So we are going to convert this into standard normalized. It is in normal distribution. We are going to convert into standard normal distribution. For that, the formula is z is equal to x minus nu by sigma. So from that, we are going to get the z value as minus 0.8. So we are going to plot the graph using this z value, and we are going to find that. So p of x greater than 26 less than 40 becomes p of z greater than or equal to minus 0.8 but less than 2. So from this, we are going to take the values of 0.8 and 2 from the z tables, as we already mentioned. So the values are 0.2881 plus 0.4772. So the final answer you get is 0.7653. And again, we are going to find the probability of x greater than or equal to 45. Again, same way, z is equal to x minus mu by sigma. You're going to get the value of z as 3. Now plot a graph and then take the intervals as p of x greater than or equal to 45 becomes p of z greater than or equal to 3. That is equal to 0.5 minus 0.49865. The final answer is 0.00135. So area under the graph is 0.00135. As we already know, area under the graph is nothing but the normal distribution of that particular thing. So normal distribution is 0.00135. So this is another example which we are going to see. The average daily sale of 550 branch offices was rupees 150,000 and standard deviation is rupees 15. Assume the distribution to be normal. Indicate how many branches have sales between rupees 1,25,000 to 1,45,000 and 1,40,000 to 1,60,000. From the question, we'll get to know that mean is nu, that is 150. Standard deviation sigma is 50. So when x is equal to 125, z is equal to 1.667. And for x is equal to 145, z is equal to minus 0.33. So for these 2 points, you are going to find the graph, you are going to draw the graph, and then the interval becomes P of minus 1.667, Z greater than or equal to P of 1.667, but less than or equal to minus 0.33. So you're going to take the values from the table of Z, and the values are 0.4525 minus 0.1293, and your final answer is 0.323. Therefore, the number of branches having sales between 125,000 to 145,000 is 550 into 0.323. That is 178 branches will be having this range. So the next condition is when x is equal to 140, the z value is minus 0.67. And for this, you're going to again find the normal distribution table, z value, and you're going to plot the graph, and the p distribution will become p of minus 0.67 greater than z or less than 0.67. So here you're going to take the values again from the z table. The values are 2 into 0.2486. So the final value is 0.4972. Therefore, the number of branches having sales between rupees 140 and rupees 160,000 is 550 into 0.4972. That is 273 companies will be having this sales between these range rupees 1,40,000 to 1,60,000. I hope you understood this session. Thank you so much.